Good afternoon and welcome to this Future Homes Hub webinar on the interim Part L of Future Homes Standard. My name is Adam Gravely, Head of Technical and Innovation for the Future Homes Hub. So firstly, I wanted to start off by introducing the Future Homes Hub, why we're here, how we're working and what we're hoping to achieve. We're an independent organisation, part funded by industry and government, set up to work across the sector on a long-term delivery plan, which we published in July last year. We're working with over 40 home builders already, facilitating collaboration across the four main domains that set out in the plan, with our first working groups focused on whole life carbon and the interim changes to the building regulations that we will dig into today. Now, every developer will need to go through a similar change programme to meet not just the Future Home Standard, but the wider set of goals in our delivery plan. And rather than this change being managed separately by 2,500 individual home builders, the purpose of the hub is to facilitate collaboration and innovation across the sector with the supply chain and with a range of expert bodies required to achieve these goals. We're bringing together the right people to answer the right questions at the right time. We want to make it easy for home builders to continue to build high quality homes at scale whilst meeting the government's long-term goals. So the government has set out its intention to introduce the Future Home Standard in 2025. And today marks a milestone towards that, as the interim building regulations come into force for the approved documents parts F, L, O and S. These cover ventilation, energy and carbon, overheating and electric vehicles. There is wide agreement on the need to improve regulated standards if we, as a nation, are to meet the challenge to cut carbon emissions and avoid global climate destabilisation. And new build homes have a significant part to play. However, any transition can be difficult. Achieving our aim to build high quality homes that are zero carbon ready will almost certainly call for changes in the way that we go about designing and building homes. Therefore, the Future Homes Hub today is publishing the first of several guides that we hope will help you navigate this unfamiliar territory. We've convened a working group including both major and smaller home builders, along with technical experts who've been working to identify the practical implementation of these new regulations and how they're likely to interact. So the purpose of this webinar is to tell you what we know so far. My esteemed colleagues and guests will guide you through the key changes to the regulations and guidance. David Adams and Richard Partington will introduce the new Future Homes Hub guidance and will share, with reference to some example house types that have been modelled, what fabric specifications and technology choices are likely to be required to comply with the uplifted target emission rate, and how new overheating regulations might impact design choices. You'll hear reflections from Trudy McCormick, Technical Development Director at Keep Mode Homes, one of the developers who have been at the leading edge of considering the practical implementation of these regulations. We encourage you to submit your questions via the Q&A function as we proceed through the session, which the panel, including Oliver Novakovic, Technical and Innovation Director at Barratt Homes, and Chris Gaze, Interim Programme Director for the Hub, will address in the final section of the webinar. I'll now hand over to David to tell you more about the guidance.
Thank you to my colleague for putting me in the right position. It's great to be here and appreciate the opportunity. Before we talk through some of the themes and some of the initial learnings really from this exercise, and I'll be doing that together with Richard. I really do want to add to Adam's comment and thank the various groups that have been working on it. We've had really good input from various specialist groups. We've had great input from the steering group and also a number of manufacturers. We all know that building regs are quite complicated. Believe you me, it's been quite complicated making them simple, and hopefully that will come across in the guide. And it's very much a where to start guide. This isn't a substitute for getting specialist advice along the way, but the intention is to give you that good starting point. So without ado, I'll pass across to Richard.
David, thank you. So I'm Richard Partington. I was one of the co-writers and steering group members with David trying to put the guide together. And I'm just going to go through very quickly some of the content in the guide and explain a little bit of the structure and how we came to represent some of the example solutions in the way that we did. But just in a more general way, to think about the sort of trajectory of homes and in anticipation of the future home standard, there are some themes that probably you will recognise of the changes that we've been making. So homes have been getting progressively better insulated. So there have been measures to improve the insulation values of all of the external fabric of the home. And they've been getting progressively more airtight as another measure of retaining heat. But coupled with that principle, we need to be thinking about how a home is ventilated. So in this iteration of changes, there are also changes to Part F on ventilation. And of course, the issue is as we make the home more airtight, we have to make sure that there's enough fresh air for good indoor air quality. But we also have to think about the principle of displacing warm air, which we've worked so hard to retain as we bring new fresh air in, and the mechanisms for doing that. The other general theme that you'll be aware of is that we are being encouraged to adopt more electrical and low carbon heating systems with the intention that between now and 2025, we graduate to an environment where all new homes are heated with heat pumps or some other alternative to fossil fuel heating. And then finally, something which has been more of an issue in dense urban areas, so particularly in London, where large apartment schemes, often with single aspect dwellings, often with common services, have been demonstrating a propensity to overheat in summer. The concern now has found its way into a national building regulation, although Part O does differentiate between high-risk areas, which essentially are the central London boroughs, and moderate risk areas, which are the remainder of the country. But just to follow. Yeah. Yeah. Sorry, just to continue from overheating, there's a slide that appears to be missing, which was to actually explain some of the general themes and the content of the document. And I'll try and do that while you're looking at the main criteria for compliance. And you'll be pleased to see that Part L has retained some of the catchy acronyms that we've had in previous iterations, but be very careful because they have changed slightly. In terms of the content of the guide, overheating is one of the things that we weren't anticipating having to spend a lot of time thinking about, but actually discovered that it's very fundamental to thinking about the issues to do with Part L and compliance with Part L. And the reason for that is that there are some constraints on the disposition and amount of glazing and the aspect ratio of windows in a dwelling. And Part L generally has two kind of components that you're needed to consider. So one is limiting the amount of solar gains, so external heat coming into the home. And then the second is making sure that there's enough provision to remove heat by having adequate ventilation. And you can see one of those is tending to reduce the glazing area, the other is encouraging you to open them. So there's a tension between the two aspects of Part O, and that has an impact on thinking about Part L. So one of the things that's changed very substantially between previous iterations of the regulations and the current ones is that you have to think simultaneously about the interaction of different elements. So ventilation for Part F, reducing the propensity for overheating Part O, and limiting heat losses in Part O. So we've done some work explaining the impact of Part O. We've also done some work trying to understand the main changes in terms of fabric. So the building regulators follow the sort of sound principle of prioritizing fabric first, but unlike in previous iterations, it's absolutely essential now to consider thermal bridging. So you need to be building homes that use reliable, in terms of the terminology in the regulations, recognized details. And those recognized details have to have psi values for them that have been modeled, and your SAP assessor then has to calculate the total extent of heat losses from those thermal bridges. The other components that are new to the regulations are to do with preparing for low carbon heat, so a requirement that heating systems, and in the current interim version, you can still heat a home with gas, but you have to design the gas system in a way that it's anticipating low carbon heat. So designing for lower distribution temperatures and probably sizing larger radiators within the home. But the regulation doesn't go as far as suggesting that you, for instance, provide storage for hot water. Connecting to the grid will be another really, really important issue. And if you are installing in the home renewables in the form of PV, you're using a heat pump, so low carbon heat. If you have battery storage, or as you will be required to from today, have vehicle charging, those are all considered to be electrical assets that have to be registered with the distribution companies that distribute all of the energy around the grid. And depending on the scale of the asset that you include in your home, that can be a process of installing and then notifying, or it can be a process of applying and registering appliances, or it can be one of a much larger negotiation and discussion about a kind of neighborhood-wide solution. But it's very important that all house builders recognize the requirement to register these assets. And that's fundamental for the operation and efficient management of the grid. So you need to know what's experienced on the grid. So coming back to what we're actually having to demonstrate in terms of compliance with the regulations, there are two new components. So we'll be familiar with a target for fabric efficiency and one for reducing emissions. But in addition is a primary energy target. And this is here because as the grid decarbonizes, measuring a home's performance in terms of carbon becomes less meaningful. It becomes more important to limit the overall energy consumption. And the primary energy target is a way of measuring all of the energy use upstream of the home's actual use on site. And then finally, the fourth element of compliance is the fourth element of compliance is a set of provisions to try and make sure that what is proposed in the design of the home, so in the design SAP, is actually realized on site. And so there are a set of safeguards in a new report, the BREL report, which is really an update of an as-built SAP, where there is a requirement to ensure that any product substitutions, any changes in construction, any different materials that are used are registered in the BREL report and the SAP is updated. And that's all part of the SAP compliance procedure. And to accompany that, we now need to also provide photographic evidence of what is built. So the issue of thermal bridging comes up again because it's not only in design, but also in construction. We need to be able to show both to the building control body and the householder that there is continuity of insulation in homes, so that all of the proposals for providing good insulation are actually delivered on site. And so, So the detail of this slide is not really essential, but just to give you a flavour of the kind of implications of Part O and to represent them graphically. So there are limitations on the position of the sill height of the window, and some discussion about how that is implemented is going on now. But the purpose of it is to try and ensure that there is adequate ventilation in bedroom windows where children might be present, so that you can have safe ventilation in a warm environment. And there are other recommendations to do with the safe opening of the window that in producing the guide, we've been able to graphically draw what we think Part O says and have discussions about DULUC, about the interpretation and the implementation of Part O. Again, the absolute detail of this slide is not essential to understand, but it's trying to make the point that some of the issues that are arising in the building regulations now need to be thought about simultaneously. So if you're a small builder that doesn't have access to a body of tested and proven house types, you're designing things in a very bespoke way, perhaps in a very linear way. So you purchase a site, you do a feasibility study, you commission an architectural designer to produce the layout and house types, you then go for planning approval, you then think about how you're going to build the homes, and you think about how to build them economically and viably, and then you make a building regs application. Now, the likelihood is that you won't be able to do things in that linear fashion now, that it would be really prudent to think about overheating, because overheating has an impact on the orientation of the home, for instance, the number of west-facing homes that may be particularly vulnerable, or the amount and extent of the glazing. So thinking about overheating, sorry, more technical glitches. Yeah, I'll carry on. So thinking about overheating, for instance, in the specification of a window, may produce different window shapes and window sizes, which will then lead to a conversation with the window manufacturer about whether the aspect ratio of those windows can be produced, and a conversation about Part F and the increased provisions for background ventilation, and whether actually the ventilation can be provided through the window or through an overhead ventilator. And you could see that you might go back and reconsider some of the solutions for both Part O and Part F in a more circular and more iterative process. So we're just trying to make the point very early on that you need to understand, and your advisors need to think about the interactions between those aspects of the regulations. The next slide, which you'll have to imagine 3 typical house types. So an end of terrace, a lovely detached house, and a room in the roof house. And just to say that the house types that have been used in the modelling that David will explain in a minute, we've done our best to make them representative, and we've done our best to make them also reflect the other aspects of the new regulations that have been introduced. And it won't be a surprise to you that of the 3 types, the room in the roof house is the one that we've found hardest to demonstrate compliance. And the reason for that is because the building regulations are now reflecting good practice and design, and they are discouraging you from creating complicated geometries, and in the instance of a room in the roof home, making a lot of surface area to enclose a very small volume. So the building regulations you will find are easy to comply with the fabric standards by making simpler homes. And of course, dealing with thermal bridging will also be much simpler. Very quickly, before I hand over to David, to explain again, a lot of the work that's gone into the guide has been working with the steering group and with industry advisors to try and make sure that the solutions we propose are realistic ones. So if you refer to the notional building in the building regs, you'll see a set of target U values that the proposal is assessed against. But our solutions are actually ones that we think can be delivered. So we varied a little bit from the notional building to ensure that, for instance, a cavity wall could be constructed with readily available blocks and with insulation that is in readily available sizes. And in each of the illustrations, we have 3 levels of performance. So in the masonry guide, we've started with a base case which is familiar to everybody of using a 100mm cavity and trying to work out what you would need to do if you stick with that cavity width in order to comply. We then have a kind of middle standard which explains how the notional building is working, how thermal bridging affects different building types, and the relative ease of using either fossil fuel heating, so gas in a combination boiler or system boiler, or an air source heat pump. And you can see from the results the comparison and the effect on all of the variables in doing that. And the same principle applies to timber stud. So in timber stud, we've started with a fairly conventional 140 mil stud with insulation between the studs and no secondary layers. And that's a base point that everybody will be familiar with. And then as the fabric specification progresses, it looks at adding insulation to those studs within the tested types that the Structural Timber Association has been working on, so readily available solutions that comply with other parts of the regulation, and then suggesting what the fabric standard might be like for 2025. And finally, just as I move on and hand over to David on technology, an interesting slide that we've chosen to use to represent photovoltaic panels, but actually a window configuration that very directly responds to the kind of criteria that are imposed by Part O. So wider than it is tall, with a fixed light below and two elements of opening light. And I think we're going to see, amongst a lot of discussion about the impact of Part O, because it's all new to us, people evolving different solutions that comply, but they will be different from what we're doing now. David, I wish you a better
technology experience. We shall see. We'll keep talking. This certainly will be a challenge if the visuals don't come across. Worth saying, for being able to convey the principles of the Part L, we've focused on very traditional technologies. So gas heating, PV, wastewater heat recovery, as well as, of course, the fabric measures. That is not to say that other technologies can't and indeed should be considered along the way. We had about 130 models anyway, and it would just be way too complicated to explain that. Remember, this is a where to start guide. This isn't suggesting these are the optimal outcomes. That very much depends on your house designs, your philosophies, the top technologies that would work in those contexts, but it's a good starting point. So, in terms of the format of the guide, you're not meant to read the page on the right-hand side, but basically we are introducing some, before we get into the details, some general conclusions. Don't skip this page. These are really important general conclusions, and I will pick them up as I go through an example on the next page. But what we're trying to do is present information in such a way that you can start to, by examples, using those representative house types, untangle what Part L 2021 means. So there's a typical page in the guide. By the way, you can download it now. It's live on the homepage of the Future Homes Hub. And we've got 4 of these relating to the 4 house types. Basically, the mid-terrace and the end terrace are the same house type, but obviously different heat loss areas, so we have a page for each. The structure is we have all the sort of summary inputs and calculation outputs. We have a commentary that's specific to the house type on the right-hand side and some important notes underneath. For those that are perhaps a little bit more nerdy out of there, I can guarantee you hours of fun. Just looking for a minute at and zooming in, hopefully you can start to see some of these numbers, but I will just describe them. And initially, I'm going to take you through each of the 3 scenarios for the end terrace dwelling, starting with the 100 mil cavity. So a pretty typical 100 mil today. If you wanted desperate to stay with that cavity width, or indeed, maybe your homes have already been plotted, so you really need to stay with that cavity width in the interim, what would you need to do? Well, The 100 mil cavity and a U value 0.25 is quite a long way away from the notional building, that notional home that the Part L has been built around. So if you're going to have a worse performance from those walls relative to the notional, then you've got to make up for that somewhere. And indeed, in the end terrace property, that means you're having to work much harder on the roof, much harder in the floor. You've gone to triple glazing, and thermal bridging is also pretty key here. So let's just switch across for a second, and just to emphasize a point that Richard was making. Whereas in the past, you could use default values, and yes, there was some penalty, but you could build homes using the default. So it was kind of something we all knew about, but we were allowed to park. Days have gone. If you look along here, this is the contribution of each of the thermal bridges that have been shown in colours. And to give you a sense of the total energy loss associated with bridges, if you were to use the defaults, that would be half of the allowed energy loss from the home. Even if you use calculated and the best calculated psi values, thermal bridges, it's still 15% of the energy loss. So you kind of get the idea, bridges are now really important. And particularly if we take our semi-detached, in our pink sort of mauve, not sure what colour it is, 22% of that heat loss is the window lintel. So in our 100 mil cavity example, where we're having to work really hard on those other elements because we've got poor performing wall, relatively poor performing wall, we are moving those to a split lintel in order to really work hard. How far do we get? Ventilation. We're going to mechanical extract ventilation with an air pressure test of 3.5. From a fabric energy efficiency perspective, a DFE, we achieve it. Now, in this case, we've exceeded it by 3%, and that you'll see is a common theme. The minimum we've exceeded these is by 3%, simply because we are still using SAP 10.1. SAP 10.2 came out yesterday, day before. We will put these all through SAP 10.2 and recalculate. But for the time being, we've given ourselves a little bit of a margin. It's not a lot of margin, but it's a bit of a margin. So what this is saying, in order to get the DFE, the dwelling fabric energy efficiency rate, with a poor performing wall, we've had to work hard everywhere else. And I guess our general advice is, this is not a great starting place. It doesn't matter what you do with your services, that doesn't affect your DFE compliance. So you can do it, but it has a risk associated. Conscious of time, so let's move on to have a little canter through if we were to use particularly fabric performance that are aligned with the better aligned with the notional dwelling. They're pretty close, but they're not exactly the same, and we've explained why in the guide. But unsurprisingly, if we apply broadly the notional values for each of the different elements, and in this case, we have chosen mechanical extract ventilation because it gives a good benefit, then we get our DFE compliance, but we've got some flexibility in that. We're not all in a corner. We've got double glazing. We're not having to put 400 mil in the loft, just 300 mil, for instance. And we've got a more reasonable air pressure test number. Now with this one, we've maintained the gas boiler. I would point out we didn't use flue gas heat recovery. We know that's an advantage, but we also were a little concerned about the accuracy of the modelling in SAP 10.1. We will look at that again when in SAP 10.2. It will make some differences because it's showing some good advantage, I understand. We have used wastewater heat recovery from the shower, and we still put PV on the roof, and we comply for the DER and the deeper, the primary energy one that Richard expressed that's new, and we've overshot it somewhat. And the reason for that is if we remove the wastewater heat recovery, we come in under, and yet, so we could have perhaps put 1 or 2 panels on the roof for PV and just nudged in, but that really doesn't sound very sensible. If we've got inverters there, wiring there, etc., we looked at giving the homeowner some more benefit. So in short, the gas solution with the notional fabric values, unsurprisingly, gives us a good outcome. Now I'll speed up because we could obviously say, hang on a minute, let's go straight for a heat pump of some sort. In this case, we've used an air source heat pump. Same fabric, but gone for a different heating system. If we were to do that, there is no PV requirement. And indeed, as you can see here, we significantly overcomply. Cantor's passed. We've left the wastewater heat recovery in simply because from a householder perspective, that helps the hot water tank go further associated with the heat pump. And again, we cover that in detail in the graph. And it's from a running cost perspective, bearing in mind we've used May 2022 energy costs, it's slightly more expensive running than, as you can see there, compared with the gas heated solution. But again, we've put a little note in there, keep an eye out because the government's saying that they will be putting forward proposals on how they rebalance costs away from gas and away from electricity and potentially onto gas or elsewhere, certainly reducing those electricity costs that are currently supporting social and environmental tariffs. That would make quite a significant difference here. So just be aware that is in the wings. We also looked at a direct electric heated version together with a heat pump for the domestic hot water. We got this to comply. You can see it significantly over-complied. The reason we've added back in PV that wasn't required for compliance purposes is to bring the running costs down. Without that PV in place, the running costs of that particular solution, as modelled, were coming out over £1,000. And finally, the high grade fabric that Richard mentioned. So we've got higher performing walls, about 200 mil cavity in masonry terms, triple glazing, split lintels, etc. And then we've modelled those both with gas boilers and one variant with PV and one variant without PV, but with MVHR to give a sense of the effects of these different routes. So what we've tried to show is 3 different specifications, all of which comply and all of which have nuances. And in the guide that you'll see, we've put some commentary against all of those. So that's the compliance bit. But there's been a big step change that Richard also mentioned in terms of documenting and evidencing that what the design said has been undertaken on site and within the as-built SAP calculation. So there's a little process here that each house builder will need to take a number of, it's not a huge number of, but some discrete photographs of particular details, particularly those that get covered up during construction. They get sent to the SAP assessor to check against the details that they were expecting the house builder to build to, and if necessary, a feedback loop there. Those are built, then get reflected in the as-built SAP to create a building regulations England L report, a BREL report, that is passed to the house builder. Together with the photo evidence, both of those sent to building control and customer. real key to be on top of this, because these are taken as things are covered up. If you miss these steps, what are you going to do? So really one to pay some attention to, and I believe there's going to be some additional guidance on that. So finally, why read the guide? I hope what we've given you is a little bit of a taster of what's contained in that. It is aiming to give a really good, pretty broad understanding of all of the facets of both the Part L, but importantly, how you need to approach the compliance with Part L. If you take away one thing only, there are some things like energy and overheating which need to be considered much earlier on, almost certainly before planning, because it will have an impact on the design of that dwelling. And your options for kind of fixing it later are really very limited. Almost certainly you'll end up going back to planning. So that, I have to say, Part O took us a bit by surprise. And what we're wanting to make sure is that message gets across to you so you don't get taken by surprise too. Thank you very much. Oh, apologies. And now I'm passing across to Trudy to give a developer's perspective.
Thank you. Hello, everybody. I'll just move to the position. That's all right. As introduced, my name is Trudy McCormick. I'm Technical Development Director for Keepmoat Homes, and I'm really pleased that I've been invited here today to share with you our perspective on the guidance that's been issued. Keepmoat are in partnership developer. We develop 4,000 affordable homes a year across the UK, and we pride ourselves in delivering sustainable communities. So when we were asked to support the collaborative working parties, we really hoped that we would be informed with regards to the future legislation and how it would impact our designs. What I have to confess, though, is what we haven't fully appreciated was the interdependencies between the new regulations and existing regulations. And that was particularly the case with Part O, as the previous presenters have mentioned. And so it's really sort of crystallised the thought now that for good low carbon design, it needs to be a whole house holistic approach. And I think the importance of this comes to life through this design guide. From our perspective, the guide gives us clarity, which is the main thing. It not only goes through the changes of the regulations that are coming to us, it sets out clearly the challenges that we need to address. It gives guidance on how to make good decision making through the process. And it gives us some really good practical work solutions. Solutions that are scalable, solutions that are deliverable, solutions that have been developed with the supply chain based on materials that are available to the market today. The other key challenge that we have as developers is the transitional arrangements. And we've never before been asked to apply standards retrospectively on existing sites. And we believe we're going to have an excess of 77 sites that are going to be impacted by the regulatory requirements. And so what was particularly pleasing is in the modelling that's been done, that it has started from 100 mil cavity, because unfortunately that is the start reality of where a number of developers will be at in developing or implementing Part L on existing sites within the constraints of existing planning permissions. So the fact that the guidance has covered 100 mil cavity and then worked its way all the way through to support developers that actively want to develop future home standard solutions now, I think is an incredibly valuable part of the tool. Throughout all the solutions, though, the common theme that comes out clearly is the importance of focusing on fabric. It's the importance of making sure we don't waste energy. And the information that's just been shared with you, particularly with regards to thermal bridging detailing, I think is incredibly valuable. It's very visual and it shows you as a developer where to focus your time. What's going to give the most benefit to your homes and team designs. The fact that the models have been undertaken with a variety of low carbon technologies, another great benefit. There's a lot of innovation in the industry, and it's nice to know that provided your home meets the constraints required to maximise the efficiency of these technologies, that they can provide good, solid, competent solutions. And finally, generation, with a gentle nod, not mentioned, but the importance of storage of energy generated to maximise that self-consumption to address running costs. And then finally, of course, and we did touch on it, the as-built quality. That is going to be a major focus for all developers going forward. These homes do need to perform as they've been designed. And photography is one way, but there's going to be a lot of work required to actually ensure that we do deliver competently and consistently to these standards. So I think to close, as everybody recognise, we are entering a period of significant change. It's going to impact the way we design our homes. It's going to impact the way the technologies we put in our homes and the way that we deliver our homes. And for me, talking on behalf as a developer, I think the guide that's been developed is a fantastic support in helping navigate our way forward to a situation where hopefully this will become the norm. Okay, thank you. I'll hand over to Oliver.
We'll come and sit at the front, Trudy. Do you want to come back for us? Thank you. Might move your chairs forward a bit. So I suppose first I'm going to say apologies to the people that have been watching. It's a shame really because David and Richard were taking you through a very detailed breakdown of the report and how to deal with the 21 some of the issues and challenges, but we've sent them on the chat, so you'll see the slides there. Please do take the time to look through it. Trudy said that there's a lot of great data there to help the industry move forward. And I said, and thanks to Trudy as well. I mean, I think it's very clear that we've got some major consequential impacts. Concentrate on fabric first and some significant change. So we're going to move to Q&As, if that's okay. So the first question that I wrote down was around overheating. And it was the simplified method. Is it just non-mechanical openings which can be used for removing excess heat? Or are we allowed to use fans or cooling within the solution?
So I'm not a simplified method guru, but no, it is basically openings.
Yeah.
You would need to move to the dynamic model to be able to capture the benefits of mechanical ventilation.
Yeah. I agree.
So,
got that one right.
Yeah.
So the next question is the 15% fabric uplift required with building regs Part L 2021 with a 31% reduction in carbon? Do you have to do the 15% uplift?
So
fabric, it might be worth explaining.
Yeah, the way it works is the 15% improvement in fabric gives you a sense of how much better the fabric needs to be. But actually, it's the outcome of taking your dwelling and applying the notional fabric standards to that particular dwelling. In other words, if you are putting a wall or roof or floor, whichever it is, that is better performing than that notional assumed, you will be on the right side of compliance. If you put a worse performing fabric in that aspect, you'll be on the wrong side and you'd have to improve something else. So actually, it's all about looking at the model itself and putting in fabric combinations guided, if you want a starting point, by the notional, that are listed at the back of the guide. And that's where the compliance comes from. It just so happens to equate to 15% for on average.
Yeah.
But that's not the
It's a rule
guiding
of
principle.
thumb, I think, to
It's
start.
rule of thumb, and it's quite a misleading one. Yeah, particularly when we get to the future home standard, when they're talking about 75 or 80%, it's very much a rule of thumb at that level.
Let's
Focus on that.
work out 2021 first, shall we?
Okay.
But Oliver, the other thing to remember is that the sort of basic principle that's always been embedded in the England regulations is that you must comply with the fabric standard. You can't compensate by using technology, say, for a facade that's fully glazed. So you have to comply with the fabric standard. So the percentage differences are really not very meaningful because you have that first hurdle to get over.
So if we expand on that bit, Richard, I think you know, as it's commonly named DFE or DFEE, that is really the regulation pushing us towards fabric first, isn't it? I mean, that's pretty much saying it's not just, you know, previous regulations allowed us to sort of move between different elements and change the U values. Now we're being a bit more prescriptive. But is it fair to say that this regulation, you know, you should start with the fabric, know what you want to get to, and then move on to the other parts? So how would you?
I would say what we've discovered is it's very difficult to comply unless you start with the fabric. You simply just won't get it to work. So you have to be thinking about the shape of the home, where the thermal bridges are, the amount of glazing and specification for the glazing.
So just expand on the shape of the home. What do you mean? Do you mean like 2.5 bedroom, box, things like that? Is that what you mean, or what?
So if you imagined, I can recall the image we had of a room in the roof. So if you imagined a home that had 2 dormer windows, for instance. So what you've created there are 3 conditions for additional heat loss. If you compare that home with, say, a home that was simpler with the same usable area. So the first one is you've increased the surface area. So you've got more heat being lost from conduction. The next one is that you've increased the number of geometric conditions. So every time the home changes direction, you have more heat loss.
So orientation?
No, just the complexity of the shapes.
Okay.
So the interlocking shapes. Okay. And then you've got more different materials meeting in different conditions. So the wall is dormer meeting roof. So
more bridging. Yeah.
Thermal bridges for the linear ones rather than geometric ones. So there's 3 extra ways that you're losing.
So if I'm sat here now, thinking, you know, it was hard enough for me to do 2013 regulations. It's fair to say that this is a much more complex reg, and the report, I think, hopefully takes the reader through those different aspects to consider, which is hard to get over in a 30-minute presentation.
It's hard for 2 reasons. So one is just the principles of retaining heat, you know, which are to do with shape and geometry. The other one is to do with the accessibility of information to help you with things like those thermal bridging details. So the building regs currently refer to recognized details by LAPC. Unfortunately, that's not a helpful reference because those details are out of date. And what we desperately need are details that reflect the current U-value constructions that have been modeled for thermal bridging. And that's why there's the commitment from STA and Masonry Alliance. There's a big hole. There's a big hole. Okay. And that impacts the smaller builder who doesn't have the resources to do custom thermal bridging modeling.
I'm going to stop. Just, I've got one other question because I know how deep we can get into this. So the other question I had is, can you confirm what the heat emitter type was?
The heat emitter for the modelling was a radiators. Yeah.
That was an easy one.
Absolutely.
I just want to bring,
Or at least from a heat pump.
yeah.
Sorry, from a gas
gas,
from gas and yeah, it was for the direct electric. Actually, doesn't matter with INSAT.
So I just want to move, Chris. So a little bit, you've probably been a little bit more outside of the detailed stuff these 2 guys are being. I just wanted to ask, you know, what maybe your takeaway has been from a Future Homes Hub point of view, as to what's maybe struck you as the thing that the people listening to this that are going to have to jump into this regulation. What's so we've heard shape, we've heard concrete, we've heard fabric. There's lots of more things you've got to think about now than you would have previously. Is there anything else that you think that the listeners should be
I think the two big surprises from the report is the impact of Part O, which Berger mentioned before, and in particular how you have to think about that pretty much before you think about anything else. It's going to, you know, all that solar gain that you took in the winter, which was great for you in SAP, is now your enemy in Part O during the summer. So I think that's the sort of the first thing. I mean, and also the constraints within Part O. There are physical constraints laid down within the regulations, which you have to be aware of. I think the other thing that's been really interesting is actually there are still a good range of different options for compliance with Part O. And I think that you know, the heat pumps are good. You've got a number of options with heat pumps which are coming forward, some of which we've not been able to model. So some you know, using networks, which we cannot yet model because we haven't got the SAP tools available yet to do that. But also if you're moving away from when people are wanting to move away from gas, you know, for the smaller dwellings, seeing how that you can actually do models where direct electric, the space heating, but heat pumps for domestic hot water still bear out for you. I think that's you know, seeing those as options available. I think and some of those options were surprises to me. I think it's really great to see that coming out to the work.
Okay, so the two for me, so just to summarise, so Part O is important, plays an important role in doing Part L. And I'm going to come to you through with that Part O very shortly, just to say what would be the three things on Part O you tell our listeners to listen out for or look out for. And the second one is actually there are options. So don't think there's just a single way of attacking this to solve it. There are a number of ways between the type of technology used from the heating process through to how you deliver that heat and other aspects. Yeah. Okay, so those are the two. Overheating, we've talked about it, but obviously this is a Part L requirement, and that's what we've been speaking about. So if I was a listener, I'd be thinking, well, one, what's Part O, overheating, and why is it playing an important part? So I know you and me have been working on this. What would be the 2-3 things, you know, without getting too technical as we can do, but what would you say look out for with Part O when the guys get to it?
I think for me, one of the key things to check is your strategy for protection against falls. Because the way the regulation has been written, if you're relying on the window to open to have improved ventilation, then currently the distance from the floor to the opening part of your light is 1100 millimeters. Unless you can introduce different types of fall protection, and trying to align that strategy with the aesthetics of the home, customer satisfaction, fire escape is a big consideration. And I think particularly in meeting other requirements such as building for health and life, working with your planners, I think getting your elevation and window styles right at the start is a key part.
So again, sorry, summarising thinking. So there's a requirement in Part O for an 1100 height. It would be fair to say that most developers still heights will be around 800 to 900.
Yes, with
so
the
you've suddenly got
1200,
this
absolutely,
big lift up
yes.
that you've got to take account. And if you look at the report that David and Richard have pulled together, there is a little section in Part O that highlights that stuff. The other one I think is it worth saying is the simplified method might not be simple. No. So for our listeners, when you'll hear these guys talking about a simplified method, I think it's worth having a look at. The Hub are going to bring some documentation about overheating that will help hopefully simplify Part O for you a little bit, but it is still complex, isn't it? I think that would be fair to say.
It is complex, and it's obviously moving us down the route of having to have each house type dynamically simulated, and that's expensive and slow. But it's the route that you will have to take if you want to look at alternatives.
Brilliant. So I've got 6 minutes, and I'm going to do one of these things where I'll start asking you guys, for the listeners, your 2 things you think they should take away from the report. I know Chris, you've already said that I have to add some to it. But if you were, if you're a listener to the small house builder or an architect or whoever's on the things, so maybe from a design point of view, Richard, what would be the 2 things that you would take away if I'm an architect sat listening to this, or a housing designer within a developer? What would you say are the 2 design things to take away?
I mean, the first thing that you absolutely have to do is change the way that you approach the planning process. So that's 2 things. One, anticipating what's going to be needed in building regulations and making designs that are going to be easy to demonstrate compliance later on. But the other thing is resisting some of the pressures in the planning system to add knobbly bits and pieces of decoration and funny roof lines and chimneys that don't do anything, and bay windows, all of the things that are running counter to Part L. So your designer needs to be really clear and be able to articulate really strong ideas for why you do things in a certain way there, because we can't have this different views of the world.
So less flexibility,
unfortunately,
for design,
but other opportunities.
but there are, it's not impossible, it's just something, and probably, and we are working and talking to planners as well to try and make them and inform them. Chris, from you, not such technical.
Yeah.
So if I'm listening, what might I want to do with my supply chain or people like that? What,
I didn't think you were going to ask me that
No,
question.
well,
I had an
that's-
answer, and it wasn't the answer to that question.
Well, you can, if you're short on my question, you can have your other answer. What would you, because you've worked a lot with logistics, supply chains and frame and all that, what would you say to, you know, if I'm a house builder and I've got all these changes, what should I be doing with my supply chain?
I think with supply chain, I think the message is keep talking to your supply chain, particularly, and if you've got new people you're introducing, talk to them really early. So our experience of talking to, so for example, if you're saying, well, I'm going to move away from gas boilers, I'm going to move over to heat pumps or some other direct electric solution. Our experience going through this project has been that these guys are falling over themselves really to talk to you as specifiers, as developers, to help you through that process. So I think the first thing is talk to them. They'll help you with designing. They'll also help you if you're struggling with installs. I think the other thing to bear in mind, of course, is that there are a lot of supply constraints out there for all sorts of things. Anything containing a silicon chip, which is amazing how many things contain silicon chips, but certainly heat pumps contain silicon chips. Anything like that, which could be subject to other supply chain constraints. Bit of a worry. Make sure that folk know your forecast for building out from.
Brilliant. And I think, is it worth highlighting that start speaking to your trades?
Start speaking to your trades.
Because they're
Yes,
going to need
yeah.
different
Yeah.
kinds of skill sets, aren't they?
Yeah.
So, David, from you, I'll let you be the technical guy in the so for the technical guys in the audience, is there anything that we may have missed or you want to reiterate regarding what should the guys be thinking about from a technical point of view?
I think there are lots of options here. Think about them early before they start getting designed out, because it's very easy to keep going back. If I could, because it's 30 pages and we had lots of debate as, can we make it shorter? Yeah. What I would ask all of the audience to do is read every page. Yeah. Even if you get through it and
Take a month.
The point
Read every
is,
page.
if you don't, the worry is you will miss something and you will find out about it, but potentially too late. Yeah. So actually, it is, I think, yes, I'm techie. We try to write it in a very readable way, and that actually gives you a really good basis to then question people and ask the right questions.
Yeah, definitely. So start early. And unlike other regs, there's so many changes. You've got to know them all.
Yes, and this is a good starting point. Frankly, then you can start talking in the right language to the technical guys.
Drew, to finish with you, customers.
Thank you.
So I was going to ask you,
yes.
what if I'm listening now?
Yes,
What's the thing I should be thinking about for my customers?
we've talked about the importance of having our homes perform. The performance of the homes will be dictated by occupational behaviour. And we need to do a lot to support our customers, to educate them on the changes, how to use the homes efficiently. We need to give consideration to the controls, the reactivity of the heating system. It's okay having products that look good inside, but then what we need to do is look at it with customer eyes. How will the customer engage with this technology? Will they enjoy living in this home? And very, it will fail if we don't bring our customers on.
Brilliant. Well, thanks very much, guys. I think we're pretty much at a point. So I think for me, hopefully, do look at the slides, because actually the slides are a great introduction to the report. Do look at all the report, read it, take your time reading it. and feedback to us.
Yes, please.
Please, this is the first report from the Future Homes Hub, but one of many that are coming. So many of the aspects in there. Customers are critical. Start early on this journey, even if you haven't got a house for a few months. Start early. I'd like to thank all the speakers and panelists for their answers. You'll get the presentation. Apologies for some of the issues, and we'll catch you soon on the next presentation again. Thanks very much, guys.
Thank you.
Thanks.